Hi, sixth graders. Today we are looking at multiplying decimals by decimals, and we are working in chapter 3, lesson 4. Today we are on page 201. Our standard that we're working in today is to fluently add, subtract, multiply, and divide multi-digit decimals using the standard algorithm for each operation. And specifically today we're looking at multiplication and multiplying with multi-digit decimals. So we are looking at a science example with the planets. The table shows the weight of a 1 pound object on each planet. So on Earth, that's our 1 pound reference that we're looking at. Number 1 asks us, and then we can see how much that 1 pound object will weigh on all of the different planets. Number 1 asks us a question about a cheeseburger. So first of all, they're giving us just a clarifying statement here. A 1/2 pound object weighs 1/2 as much as a 1 pound object. You guys know that. Okay, so I'm just going to say that again. It's very simple. Don't get confused by that statement. A 1/2 pound object weighs 1/2 as much as a 1 pound object. Okay. If a cheeseburger weighs a 1/2 pound on Earth, what will it weigh on Jupiter? Okay, so it's a 1/2 pound on Earth, and we want to know what that will weigh on Jupiter. So what we need to do is compare the weight of an object on Earth to the weight of an object on Jupiter. Okay, so when we do that, going from Earth to Jupiter, an object is going to weigh 2.3 times as much. Okay, so if it weighs 1 pound on Earth, it'll weigh 2.3 pounds on Jupiter. So going from Earth to Jupiter increases the weight by a factor. Remember, factor is multiplying by a factor of 2.3. So we're multiplying. That's the multiplication dot. So we're multiplying by 2.3 to go from Earth to Jupiter. So if our cheeseburger weighs a 1/2 pound on Earth, what will it weigh on Jupiter? So it's going to weigh 2.3 times as much. So what we're doing is this problem, we're doing 2.3 multiplied by 1/2 pound. 1/2 pound would be written as 0.5. So 2.3 times 0.5. And then we want to multiply. So when we're multiplying decimals, we start off by actually ignoring the decimals, and we multiply it like we would with whole numbers. And then we need to go back in and count how many decimals we had to begin with and make sure we have that same number in our total. Okay, so, and I'll explain that to you right up here. Let's just kind of talk about why we do that. It makes more sense when you compare it to fractions because we already know how to do this with fractions. We just don't do it a lot with decimals. So if you think of 1/10 of something, and you multiply it by 1/10. Remember that of means multiply. So if I'm taking 1/10 of 1/10, okay, so if you have 1/10 of something, and then you take this, so that's a small portion of something, and then you take 1/10 of 1/10, what portion of that do you have now? Okay, I'm going to ask that question again. If you have 1/10 of something, and then you have, so 10 people are sharing whatever you have, whatever object you have. Okay, 10 people are sharing. Now you have that 1/10 that you have, and you now have to share that with 10 people total, yourself plus 9 other people. So what is 1/10 of 1/10? 1/100th. Okay, so we think of it in terms of fractions. We're a little bit more comfortable with that than we are necessarily with decimals. So 1/10 of 1/10 is 1/100th. So when we think of this as decimals, remember 1/10 is just 0.1 times 1/10, 0.1, okay? So 1/10 times 1/10, 0.1 times 0.1. 1 times 1 is 1. Okay, and then we have how many decimals in our problem? 1, 2. So we need how many decimals in our answer? 1, 2. Our decimal goes here, and we annex zeros in those empty spaces. So how do we read this number? 1/100th. How do we read this number? 1/100th. Okay, so these are equivalent. This is just written in as fractions, and this is written as decimals. Either way you look at it, it's 1/10 times 1/10 equals 1/100th. 1/10 times 1/10 equals 1/100th. Okay, so we're a little bit more familiar with it than we realize because of our fraction work in elementary school. So we're doing the same thing, but now we're just expressing those same numbers, 1/10, but we're expressing it as a decimal instead of a fraction. Okay, so it's not really new math, it's just a different representation of the same math that we've been working with all throughout elementary school. So here we have back to our cheeseburger problem, we have 2.3 times 0.5. So we're going to multiply 2.3 times 0.5. So 2 3/10. I'm going to do a squiggly line here just to really separate. This is the new problem. 2 3/10 times 5/10. And remember, initially we're just going to multiply like we would with regular whole numbers. And then once we get our answer, we will add in our 1, 2 decimal places because we have 2 decimals in the problem. We will need 2 decimals in the answer. So 5 times 3 is 15. Write the 5, carry the 1. 5 times 2 is 10, plus the 1 we carried is 11. So 115. So if these were whole numbers, it would be 23 times 5 would be 115. That's a reasonable answer. But they weren't whole numbers, they were decimals. So we have 1, 2 decimal places in our problem. We need 1, 2 decimal places in our answer. So that cheeseburger would weigh 1.15 pounds on, what was our planet? Jupiter. Okay, so 1.15 pounds on Jupiter. Number 2, what would a barbell that weighs 5 pounds on Earth weigh on Jupiter? Okay, so again, we're going from Earth to Jupiter, so it's going to be times 2.3. It's going to weigh 2.3 times as much. Okay, and by the way, the science connection here is, so Jupiter is a very large planet, and the larger, the more massive, the more mass that a planet has, the stronger its gravitational pull. So that's why things are heavier on the larger planets, because they just have more mass kind of attracting objects to them. So what would a 5-pound barbell, something that weighs 5 pounds on Earth, how much would it weigh on Jupiter? So that's just going to be 2.3 times 5. So we can do that math. Let's do it over here by the barbell guy. 2.3 times 5. Okay, and again, we're just going to multiply as if there weren't any decimals, and then we'll add those decimals back in at the end. 5 times 3 is 15. Write the 5, carry the 1. 5 times 2 is 10, plus the 1 we carried is 11. We had 1 decimal in our problem. We need 1 decimal in our answer, so 11.5 pounds. And LB is the abbreviation for pounds, okay? It's Latin, I believe it's Latin for libra, okay, which is like those scales. If you can kind of think of the old-fashioned scales for weighing things, that was called a libra. It's also an astrological sign. All right, number 3, use the results from exercise 1 and 2 to find 0.05 times 2.3. So this problem, I'm just going to write the problem here horizontally, was 2.3 times 5. Okay, so that's off my camera. I just wanted to record it. That's what we did. Okay, so here we're multiplying by the 2.3, and here we have a 2.3 as well. Here we multiplied by 5, and we got 11.5. We multiplied by, here we multiplied by 0.5, and we got 1.15. Okay, so it got smaller by a factor of 10. This was a 5. 5/10 is 10 times smaller than 5. Okay, and then 5/100 is 10 times smaller than 5/10. So all we're doing each time is we're dividing by 10, an additional factor of 10. So this was 11.5 when we multiplied by when we multiplied by 5. Here by 0.5, our decimal was 1 place farther to the left. Here, if we're multiplying by 0.05, our decimal will be 1 place farther to the left than it was here. So it'll be 0.115, okay? 0.115 pounds. Okay, and let's just prove that with our problem. So 2.3 times 0.05. This has 3 digits, even though well, yeah, this has 3 digits. I'm just going to go ahead and write that in the, it doesn't matter if you're writing the top row or bottom row. Aesthetically, I think it just looks nicer to have the longer number on top, but you don't have to do it that way. So 0.05 times 2.3, 3 times 5 is 15. Write the 5, carry the 1. 3 times 0 is 0, plus the 1 we carried is 1. 2 times 5 is 10. Write the 0, carry the 1. 2 times 0 is 0, plus the 1 we carried is 1. So we have 5, 1, and 1, and we're not surprised. We expected to get those numbers, the 115, 115, 115. The question was just, where is our decimal place going to belong here? So how many decimals were in our problem? Well, we have 1 here, 2, 3. So altogether there were 1, 2, 3 decimals. So in our answer, we need to have 1, 2, 3 decimal places. So this is 0.115 pounds. Okay, so here in this where we're looking at 11.5, 1.15, 0.115, that is, we're looking at a pattern there where we recognize that there was a pattern here. So that would be repeated reasoning and making use of structure. So we saw that repeating pattern, we saw the structure of the repeated pattern, and we recognized what our answer was going to be here. We persevered. Okay, so multiplying multiple digit decimals is not really simple and easy. You do need to be very careful and precise in your numbers. Okay, speaking of precision, we have to attend to precision. We need to know our math facts. And if we don't know our math facts, we need to slow down and take the time necessary to make sure that we are multiplying correctly. And if you don't know your math facts, one of my favorite I think it's a .com. It might be a .org, but I think it's a .com. One of my favorite websites for helping to memorize your math facts is extramath.com. It's a very straightforward, just practice, practice, practice memorizing your math facts. And there is a guy on there, I think he's a teacher, and just kind of helps you with those problems. So that's a nice, very straightforward, simple website. It's free. If you use it on your computer or Chromebook, and I think if you do it on your tablet or phone, it's like maybe $5 or something like that. So extramath.com is free on computers and Chromebooks if you just need to refresh your math, basic math facts. Okay, so let's turn the page to 202. Okay, when multiplying a decimal by a decimal, multiply as with whole numbers. So do the same thing that you would with whole numbers. Then to place the decimal point, find the sum of the number of decimal places in each factor. Factors are the things we're multiplying together. So count how many decimals were in your factor. Your product, which is the answer to the multiplication problem, the product has the same number of decimal places. So when we have 3.6 times 0.05, okay, and remember how I said I personally prefer to have the longer number on top. Okay, the advantage of putting if you just have one digit there, do you see how over here I actually had, back down here, yeah, I had 2 rows to add together. And so if you did it this way, you would actually only have had 1 row. So there's an advantage to doing it that way as well. Just 1 row and that's your answer. But that just happened because there were so many zeros in that row. Normally it's faster the other way. Okay, but anyway, you can set it up either way, and the multiplication, as long as you're multiplying correctly, you'll get the same answer. And so we have 3.6 times 0.05, so 3 6/10 times 5/100. We multiply 5 times 6 is 30. We write the 0. We carry our 3. 5 times 3 is 15, plus the 3 we carried is 18. We write the 18. We had 1, 2, 3 decimals in our problem, so we need 1, 2, 3 decimals in our answer. So the product is 0.180 or 18/100. Okay, let's take a look at number 2 on page 202. So first we're going to estimate 0.112 is pretty close to 0, so I'm just going to call that 0, and 7.2 is pretty close to 7, so I'm going to say my answer should be pretty close to 0. Okay, so 0.112 has 3 decimal places, 7.2 has one decimal place. So our product will have the 3 plus 1, a total of 4 decimal places. So we can go ahead and multiply and know that our answer should be very close to 0. Okay, so definitely between 0 and 1. So if I get an answer of like 10 or 11, then I know my decimal is in the wrong place. That's why we do the estimation. Okay, it helps us to know that our decimal is in the correct place. Next, so let's go ahead and multiply 0.112 times 7.2. 0.112 times 7.2. 2 times 2 is 4, 2 times 1 is 2, 2 times 1 is 2. Moving on to the 7. 7 times 2 is 14, write the 4, carry the 1. 7 times 1 is 7, plus 1 is 8. 7 times 1 is 7. Okay, then we're adding up. We have 4, 6, 10, write the 0, carry the 1, 8. And then we had 1, oh, we already set up here. We would need 4 decimal places, but 1, 2, 3, 4 decimal places. 1, 2, 3, 4 decimal places. And right here, we annex a 0, okay? So that means our product is 0.8064. Check for reasonableness. Our estimate was 0, and that is very close to 0.8064. So it's close to 0. And then we have 3 sample problems down here. Got it A, got it B, got it C. And I'm just going to show the work over on the side of the page over here in the work zone to the left because well, actually, yeah, I think we can fit these in here. Yeah, we can definitely. This one we'll write small on that third one. So we have 5.7 times 2.8. I'm just going to zoom in and write pretty small. You can use the work zone if you want to. Just because I'm on the camera, I'm going to do it here. So 5.7 times 2.8. Okay. We have, let me see if I can focus that a little bit. It's pretty close. 7 times 8 is 56. Write the 6. Carry the 5. 8 times 5 is 40. Plus the 5 we carried is 45. Now I move over to the 2, which means I'm writing underneath the 2. So 2 times 7 is 14. Write the 4, carry a 1. 2 times 5 is 10, plus the 1 we carried is 11. And then we add these up. We get 6. I don't have my whiteout handy, so I'll just write over the top of this. We have 6, 9, 5, and 1. I was going to white out that little, but it's fine. And then in our problem, we had 1, 2 decimals. So in our answer, we need 1, 2 decimals. So this is 15.96. 15 and 96/100. Let's look at got it B. We have 4.12 times 0.05. 5 times 2 is 10. Write the 0, carry the 1. 5 times 1 is 5, plus the 1 we carried is 6. 5 times 4 is 20. We had 1, 2, 3, 4 decimals in our problem. So we need 1, 2, 3, 4 decimals in our answer. So our answer is 0.2060 or 0.206. In high school, when you're taking classes where we're really being precise, like chemistry, we would keep that 0. They'll teach you about that in high school. It's called a significant digit. But for our purposes, we can drop that 0 at the end. We don't have to be that precise in 6th grade. So 0.206 is a good answer for us. Okay. And just so you know, this 0.2060 is actually 10 times as precise as this 0.206. So when we always tell you in elementary school, you can drop the 0, it doesn't matter. We just don't want to confuse you when you're little, but actually you'll learn as you move up to higher levels of math and science, that actually helps us to be like really precise. So each time you move over 1 decimal place, you're becoming 10 times more precise. or less precise if you're moving your decimal in the other direction. Okay, and let's look at got it C. 0.014 times 3.7. Okay, 7 times 4 is 28. We write the 8, we carry the 2. 7 times 1 is 7, plus the 2 we carried is 9. And then you can write these zeros or you can leave the zeros. It's totally up to you and whichever way you learned and are most comfortable with. I'm going to erase this 2 that we carried here because we're moving on to the 3. And it's making my 0.14 look like a 7.4. Okay. All right, then, in fact, I want to check my math there. Yeah, that's good. All right, and then I'm moving on to the 3. 3 times 4 is 12, so I'm going to write my 2, carry the 1. 3 times 1 is 3, plus the 1 we carried is 4. And we add these up, 8. 9 plus 2 is 11, write the 1, carry the 1, and then 4 plus 1 is 5. And then in our problem, we had 1, 2, 3, 4 decimals all together. So in our answer, we need 1, 2, 3, 4 decimals, and we annex a 0 in that spot as a placeholder. So our answer is 0.0518. 0.0518. So that's 518. What? Do you know what this place value is called? This is the tenths place. This is the hundredths place. This is the thousandths place. This is the 10,000ths place. Okay, so this is 518. We read the number, just ignoring the zeros and the decimals. So 518, 10,000ths is how we read that number. Okay, again, this is the tenths, hundredths, thousandths, 10,000ths. So when we read this number, we would read it 518 because we're ignoring the zeros and the decimals. 518, 10,000ths. When we read this number, ignore the 0 and the decimal. This is 206. This is tenths, hundredths, thousandths. So this would be 206 thousandths. And you might be saying, well, I'm not memorizing that. That's a waste of my time. I don't want to learn those. I don't need to learn those. I'm just going to say 0.206 and be done with it. Okay, well, the reason that it's valuable for you to learn what the place values are is because it's going to help you to be able to switch between fractions and decimals. So if I read this decimal, this is tenths, hundredths, thousandths, right? So if I wanted to write that as a fraction, I can do that very easily if I know my place values. I say 206 tenths, hundred thousandths, 206 thousandths. Okay, so that's a valuable skill. So learning those place values, super easy, right? This one's called tenths, and you add a 0 each time. Tenths, hundredths, thousandths, 10,000ths. Done. Okay, it's not that difficult. No trick. The first one is the tenths place, then the hundredths, then the thousandths, then the 10,000ths. That's it. All right, page 203. If there aren't enough zeros, or if there aren't enough decimal places in the product, you need to annex zeros to the left, and we've kind of already been doing that. So we'll have some formal practice here. Find 1.4 times 0.067. So I like the longer number on top. I know this is worked out here, but let's go ahead and do it in our book. Remember, anything I write in notes, you write in notes, okay? I already passed 6th grade math a long time ago. Okay, so this is for you. Anything I'm writing, you are writing. So let's go ahead and do this work right here. Also, when you see this symbol, okay, the tutor button, that means that if you want to go in your online textbook, you can watch a video of a teacher working out this problem. Okay, so right in your online textbook, you log in, you go to chapter 3, lesson 4, and that'll be one of the videos, one of the sample problems that they explain to you. Okay, so let's go ahead and do that together though. Since we're here, we have 0.067 times 1.4. And I'm always very precise. I line these up neatly. I know some teachers give you graph paper. I think that's a really nice tool, especially if you're a sloppy writer. or you just are worried about making a mistake, okay, the graph paper is a really nice tool. I don't give out graph paper. I think you just need to practice being precise, practice having rows and columns that are consistently spaced. And I think the more you do that, the better you get at it. But if you feel like you need graph paper, that's a personal decision. And there are a lot of like free sites where you can just print graph paper from. All right, so let's go ahead and look at this. We have 4 times 7 is going to be 28. We write the 8, we carry the 2. 4 times 6 is 24, plus the 2 we carried is 26. Write the 6, carry the 2. 4 times 0 is 0, plus the 2 we carried is 2. Then we move on to the 1. 1 times 7 is 7. 1 times 6 is 6. And then you can or cannot multiply those zeros. That's personal preference. Let's leave them off just because we're actually practicing annexing zeros. So let's just intentionally not bring them over. Okay. So then we add. We have 8 plus nothing is 8. 6 plus 7, right? 6 plus 6 is 12. So 6 plus 7 is 1 more, 13. Write the 3, carry the 1, 6, 8, 9. And then we had 1, 2, 3, 4 total decimal places in our problem. Let's look at that again. 1, 2, 3, 4 total decimal places in our problem. So we need 4 total decimal places in our answer. 1, 2, 3. We're out of numbers. Okay, 4. So what goes in that empty space? We annex a 0. And then in math, we always want to have a 0 to the left. So it's obvious that that's a decimal place there. So 0.0938. Okay, and there's the notation. We do need that 0 to the left of the decimal place. That's just good mathematical practice. Number 4, we have 0.45 times 0.053. The product will have blank decimal places. Annex zeros if needed. Okay, well, how many decimal places will we have? Let's count. That's a period at the end of the sentence. Okay, so just ignore that. 1, 2, 3, 4, 5. So we will have 5 decimal places in the end. Okay. They have nicely given us all the scaffolding boxes to help us to line things up. You can use that if you want, or if that's too big for you, here's a smaller space here. 3 times 5 is 15. Write the 5, carry the 1. 3 times 4 is 12, plus the 1 we carried is 13. Write the 3, carry the 1. And 3 times 0 is 0, plus the 1 we carried is 1. Moving on to the 5, and remember here I'm in the 5 column, so I start writing underneath the 5. 5 times 5 is 25. Write the 5, carry a 2. 5 times 4 is 20, plus the 2 we carried is 22. Write the 2, carry the 2. 5 times 0 is 0, plus the 2 we carried is 2. So we add. 5 plus nothing is 5. 3 plus 5 is 8. 1 plus 2 is 3. Nothing plus 2 is 2. And we said we need 5 decimal places, right? Let's double check that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our decimal place is going to go there. And we need to annex a 0 here to the right of the decimal. And we add our 0 that is always to the left of the decimal place. Multiply related whole numbers. So they're actually going to have us do this problem again just to check our math with whole numbers. We'll go ahead and do that. So if this were 45 and 53, what would our just digits be? Forget the decimal places, so we can kind of check our math. Remember, it's the same thing that we did in 5th grade with whole numbers. We're just adding decimals in our problem and making sure we account for those in our answer. So this is just one little step up from what you already know from 5th grade, multiplying multi-digit numbers. Now we're just multiplying multi-digit decimals, okay? So it is actually not harder, it's just one more step. You have decimals in your problem, so you need to make sure you have the correct number of decimals in your answer. You can do this, you got this. All right, so then we're just checking with whole numbers. 3 times 5 is 15, write the 5, carry the 1. 3 times 4 is 12, plus the 1 we carried is 13. 5 times 5 is 25, write the 5, carry the 2. 5 times 4 is 20, plus the 2 we carried is 22. Then we add 5, 8, 3, 2. 2, 8, 3, or excuse me, 2, 3, 8, 5, 2385. So we're just checking the multiplication. We're just building on what you already know from 5th grade, reminding you that you know how to do this. You already know how to do this. We're just adding in decimals this year. Let's do some sample problems. And then I don't want to try to squeeze these in down here, so I'm actually going to use the work zone. So the first problem is 0.04 times 0.32. So I'm going to put these both have 3 digits. I'm going to put this one on the top, in the top row, so I only have to multiply by 4. Okay. It doesn't really matter. It'll give me the same correct answer both ways, but this just saves me 1 row of adding. So I'm going to write this problem over here in my work zone. So got it, D is 0.32 times 0.04. Okay, so all I did was just switch those around, so I'm only having to multiply once. This is what we had, 0.04 times 0.32, and I just switched those numbers around because we can do that in math because of the commutative property. Like 2 times 5 is the same thing as 5 times 2. So I can do that multiplication in any order that's convenient for me. So this is more convenient for me, so I don't have to multiply by a 2 and a 3. I can just multiply by 4. Okay, you get the idea. So 4 times 2 is 8. 4 times 3 is 12. You can write the 2, carry the 1, or if you see that that's a 0 and you know it's just going to be 12, you can write that there. Personal preference. This is a 0, this is a 0, so there's nothing more for me to multiply. And that's why I wanted to have the 4 in the second row. And then in my problem, I have how many decimals? 1, 2, 3, 4. I have 4 decimals. So 1, 2, 3, 4 decimals. I put my decimal point here. Annex is 0 to the right of the decimal. Annex is 0 to the left of the decimal, 0.0128. So how would we read this number? We would say 128. That's our numerator, right? And then this is, if you were to write it as a fraction, it would be the numerator. Tenths, hundredths, thousandths, 10 thousandths. So if we were to write this as a fraction, we would say 128 10 thousandths, okay? And then we would simplify, obviously, those are both even numbers, okay? So in got it D, it was 0.0128. Okay, and then got it E, I have 0.26 times 0.205. This has 3 digits that we're multiplying. This has 2, so I'm going to put this number first, the 0.205 in my top row, and I'll put the 0.26 in my bottom row. So 0.205 first. I'm just working up here so I have a lot more space. So E, 0.205 times 0.26. And I'm careful. See how I lined up my 6 under the 5. I lined up the 2 under the 0. I lined this 0 up under that 2. So if I'm writing these numbers medium sized, I'm writing the numbers underneath them that same size, just so I don't get out of line. Okay, so be neat. Or even if you're not neat, be in line. Okay. 6 times 5 is 30. Write the 0. Carry the 3. 6 times 0 is 0, plus the 3 we carried is 3. 6 times 2 is 12. Write the 2. You can carry the 1, or you can just see if there's a 0 there and you can write it here. So if I carried the 1, I would say 6 times 0 is 1, plus the 1 we carried is 1. Okay, or you could just say 6 times 2 is 12. There's a 0 to the left of it, so I'll just write my 12. Either way is fine, and I know depending on who taught you, you probably are comfortable with the way that you do it, and that's fine. Stick with that. Moving on to the 2, and we'll make sure that we're writing underneath the 2. I'm just going to erase those numbers that I carried from the 6. 2 times 5 is 10. Write the 0, carry the 1. 2 times 0 is 0, plus the 1 we carried is 1. 2 times 2 is 4. Then we add, we get 0, 3, 3, and 5. And then we need to decide where to put our decimal. In our problem, we had 1, 2, 3, 4, 5 decimals. So in our answer, we need 1, 2, 3, 4, 5 decimals, and we put it, annex a 0 in that space, put a 0 to the left. So our answer is 0.05330. You can drop that last zero all the way to the right if you wish. 0.05330, or you can drop it. Okay, we don't really, oh, I'm sorry, I'm off the screen. We don't really need that in 6th grade, so this would be, I prefer this answer, but this is also correct, and I would not mark that wrong. 0.0533 or 0.0533 with 0 at the end. Okay, let's do letter F. We have 1.33 times 0.06, 1.33 times 0.06. 6 times 3 is 18, write the 8, carry the 1. 6 times 3 is 18, plus the 1 we carried is 19, write the 9, carry the 1. 6 times 1 is 6, plus the 1 we carried is 7. And then we don't have anything else to multiply in that row. We have how many decimals in our problem? 1, 2, 3, 4. So we need 4 decimals in our answer. 1, 2, 3, 4. Our decimal goes here, annex is 0 here and here. Okay, so letter F is 0.0798. All right, let's do some of the guided practice problems together. 0.6 times, actually we may do them all. Let's see how we're doing with time here. 0.6 times 0.5, 0.6 times 0.5. 5 times 6 is 30, write the 0, carry 3. 5 times 0 is 0, plus the 3 we carried is 3. Our problem has 1, 2 decimals, so our answer needs 1, 2 decimals. Annex the 0 to the left, and we end up with 0.30 or 0.3, so 3/10. Number 2, a lot of multiplication in number 2. All right, so 27.43. This one we definitely are going to be persevering with problem solving, okay? We're not using our calculator. You can use your calculator to check to make sure you're doing things correctly, so that you're, not doing 10 problems in a row wrong and then realizing. So yes, you can use your calculator to check when you get to your homework, but you should definitely be showing all your work. So you're going to be sending me a picture of your work. Your work is going to look like this work, okay? Your work is going to look like that. Maybe not as, you don't have to make it so small, but you need to be showing your work. You won't get points for not showing your work. These are non-calculator items, so we do need to be able to multiply without a calculator. Okay, so back to this fun problem, 27.43. How many digits? 1, 2, 3, 4, 1, 2, 3, 4. So it doesn't really matter which one we do on the top row. Okay. 9 times 3 is 27. Write the 7. We're going to run out of space here. Actually, let's skip that problem. We can do that on lined paper, okay? Because we're going to have 4 rows, and we won't be able to fit that in here. Let's do. You can just skip that. Number 2. 0.98 times 7.3. So this has 3 digits. That has 2. Even though that's a 0, aesthetically, I just kind of like that up there at the top row. 0.98 times 7.3. But it doesn't matter. 3 times 8 is 24. Write the 4. Carry the 2. 3 times 9 is 27. Plus the 2 we carried is 29. 7 times 8 is 56. Write the 6. Carry the 5. I'm just going to cross out that 2. 7 times 9 is 63. Plus the 5 we carried is 68. And then we add. That's why we didn't do this. We're running out of room with just 2 digits. So 4 plus nothing is 4. 9 plus 6 is 15. Write the 5, carry the 1. 8 plus 2 plus 1 is 11. Write the 1, carry the 1. 1 plus 6 is 7. So in our problem, we had 1, 2, 3 decimals. In our answer, we need 1, 2, 3 decimals. So that'll be 7.154. Okay, and number 4. 2.7 times 1.35. This has 3 digits, so I'm just going to put that in the top row. 1.35 times 2.7. 7 times 5 is 35. Write the 5, carry the 3. 7 times 3 is 21, plus the 3 we carried is 24. Write the 4, carry the 2. 7 times 1 is 7, plus the 2 we carried is 9. 5 times 2 is 10. Write the 0, carry the 1. 2 times 3 is 6, plus the 1 we carried is 7. 2 times 1 is 2. We add these up. 5, 4, 16, and the 1 we carried is 3. In our problem, we had 1, 2, 3 decimals, and I actually counted them up here, if you notice, because I had all my numbers that I carried. They were kind of in the way, so I wanted to be sure, and I counted the decimal places in the original problem. Okay, just a small detail in case you didn't notice. I counted them here, 1, 2, 3, because it was neater than in my work. 1, 2, 3. 3.645. Okay, and going pretty fast through these. Your homework is going to be a little slower, depending on how well you know your math facts. So don't get discouraged. Remember, we have 2 days before this is due because of the block schedule. So don't get stressed out. You don't have to do it all in one day. Okay, so pace yourself. You can do part of it today and part of it tomorrow. The important thing is that you're practicing it. You're not using your calculator. You take your time, double check your work, be precise. Don't get frustrated. If you get frustrated, take a break and come back to it. Okay. Number 5 is 0.03 times 0.09. Both of those have 2 digits after the decimal, so it doesn't matter which one you put first. Just no benefit either way. 9 times 3 is 27. Write the 7, carry the 2. 9 times 0 is 0, plus the 2 we carried. Okay, or you could have just written 27 here, depending on how you learned it. In our problem, we had 1, 2, 3, 4 decimal places. In our answer, we need 1, 2, 3, 4 decimal places. Annex is 0 here and here and here. So our solution is 0.0027. And how do we pronounce that number? So we ignore the zeros in the decimal, and we say 27, and then we look at the place value. Tenths, hundredths, thousandths, 10,000. So our last digit is in the 10,000ths place. So we would pronounce this, we would read this number as 27 10,000ths. Okay, and then when we wrote it as a decimal, we would say 27 10,000ths. But we're not actually doing that. I'm just kind of, when we get to the fractions lesson, kids tend to forget that and overthink it. So I'm just going to start reminding you of that now. We don't need to do that at this point, but you're just getting a little sneak peek of things to come. Okay. And then 6, we have 0.04 times 2.12. This has 3 digits. I'm going to put that on the first row. 2.12 times 0.04. 4 times 2 is 8. 4 times 1 is 4. 4 times 2 is 8. I don't need to multiply the zeros, okay? Because there are no other numbers to the left of those zeros. That's why I'm allowed to skip those. In our problem, we had 1, 2, 3, 4 decimals. In our answer, we need 1, 2, 3, 4 decimals. Annex is 0 here. So we have 0.0848. Okay, I forgot to box this answer. We want to get in the habit of boxing our answers. Our math teachers do that from 6th grade all the way up to 12th grade. Okay, it just helps to make sure that you have clearly identified your answer. So there's no question of what you meant. So when we read this, we would say 848 tenths, hundredths, thousandths, 10,000ths place. So we say 848 10,000ths. Number 7. A mile is equal to approximately 1.609 kilometers. So how many kilometers is 2.5 miles? And justify your answer. Okay, so 1 mile is 1.609 kilometers. So if we have 2.5, we have to do this 2.5 times. Okay, so it's 1.609 times 2.5. Okay, 5 times 9 is 45. Write the 5, carry the 4. 5 times 0 is 0 plus the 4 we carried is 4. 5 times 6 is 30. Write the 0, carry the 3. 5 times 1 is 5 plus the 3 we carried is 8. Then I'll erase the numbers that the number that I carried. And then moving on to the 2. 2 times 9 is 18. We were multiplying by the 2, so we write underneath the 2, 8. Carry the 1. 2 times 0 is 0, plus the 1 we carried is 1. 2 times 6 is 12. Write the 2, carry the 1. 2 times 1 is 2, plus the 1 we carried is 3. I'm kind of out of space here, so I'm just going to write my total over here. So 5 plus nothing is 5. I'm writing that on the right. 4 plus 8 is 12. Write the 2, carry the 1. 1 plus 1 is 2. 8 plus 2 is 10. Write the 0, carry the 1. And 1 plus 3 is 4. Okay, so, and then we had how many decimal places? 1, 2, 3, 4. 1, 2, 3, 4. Okay, so 1 mile is about 1.609 kilometers. So 2.5 miles would be 4.0225 kilometers. So that's reasonable. If I would have had something like 40, that would have been obvious that the decimal is in the wrong place. Building on the essential question, why is estimating not as helpful when multiplying very small numbers? We just don't have a really good grasp of small numbers, like, 7 thousandths, and sorry, my Zoom controls are on the way there. We don't have as strong of a grasp. We're not as familiar with working with very small decimals, okay? So we're working with whole numbers all the time. So let's say most people are not as accustomed to or used to working with small decimals. So that's not something that you have a point of reference to where you can just kind of imagine that in your mind very easily, because most people, let's maybe say, aren't as comfortable or familiar with decimals as they are with whole numbers. And you can put that into your own words. Okay, so in a nutshell, when we are multiplying decimals, we at first ignore the decimals and multiply as you normally would. And then second, you tally up, you count up how many decimals were in your problem, and you make sure you have that same number of decimals in your decimal places in your answer. And that is how we multiply a decimal by a decimal.